Welcome to Chapter 3 of LabView. This is John Waddick, your host. And this movie shouldn't be too long. I'm just going to show you some of the finer points. So let's get right into it. Tutorial 3.1. Instructions, if you want to follow along in the book, are page 60 to 62. The main thing here is I've got a little decoration box in the front panel, and I've got a couple of inputs. And notice that I think these are knobs. Dial is very similar, so you can use a dial or a knob. But notice how as I move this, it just goes in increments of 10. And I've got a digital display out there. Over on the block diagram, we've used while loops before. And these two inputs are the two knobs. I've got an add function and a numerical display. We've done this stuff before with the loop condition and a stop button you see here. So when we run this program, we're not going to do it in run continuous. We're going to do it in single run, and we're going to control the execution when it stops with the stop button. But the main thing is I want to show you how to deal with a dial. So let's right click, and I'm going to go into a numerical input, and I'll take a knob. Okay, so here's a knob. So it comes in with default 0 to 10. Now, first thing I'm going to do is just right click on it. We're going to do a visible item, and let's do a digital display. Okay, so then we can see what value it is. Now, right now, as you see, I can turn this. I can get any value, well, not any value, but almost like a continuous stream of decimal values between 0 and 10. Well, if my intent is to go from just 0 to 100, and I only want people to choose 10, 20, 30, 40, this is what we have to do. And I want them to be integers. So first thing is, with a little bit of hunting around, I go to data entry or representation. Okay, I don't know why they don't put this in the properties, but they don't. So I can just use a U8. That'll allow me to put any value in from 0 up to 255. Another item I'd like to have here is visible item. Let's look at the digital display. So right now I'm constraining from 0 to 10, but as you see, I can only put integers in, which is good, which is what I want. Now let's go to properties, right click, go to properties. And we're going to go into data entry. And instead of defaults, see right now a U8 data type can go up to 255. I only want to go up to 100. I want my increment to be 10. And I want to coerce, which means make it go to the nearest 10. Okay? So there's that. Now I still have to unfortunately change the scale. So even though the data entry is right, my scale, I have to make that 0 to 100. Okay, so now that it's the way I want it. All right, so now if I drag this along, notice I'm going in steps of 10, which is what I want. So you're putting two knobs in there, input 1 and 2, digital displays, and you know how to do the rest from here. So let's close this down, and let's go to the next one, which is going to be example 3.3. So well, here we are with example 3.3. Not a big deal. Now we have this new type of indicator, which is going to be called, let's see what we call it. It's going to be a meter. Okay, brought the meter in, and we want to go from 0 to 14. Now, as you guessed it, we can go to properties, and we can set up our scale. Instead of 0 to 10, I'm going to go 0 to 14. The data type, double precision, yeah, we want decimal places. I think everything else is good. Maybe just a digital display, visible item, digital display. All right, so that's all we did to create that. Over on the right side, we have this new thing, pi. So how do I get that? So just to show you, there's an input here. I can right click and I can find pi. So we want to be able to put in a value of pi over here because we want to be able to multiply up to 4 times pi. So I'm going to right click and I'll show you where to find pi. It's under numeric. Go into numeric, and then there's math constants. And there's some common things in here, including pi. So I grab pi, bring it in, and just wire it into the multiply. So when I write this or run this thing, and I'll run this in single shot mode, I can get different values. There's 1 pi, 2 pi, 3 pi, 4 pi, and I can stop it. Okay, so example 3.3, not too bad. So let's close that one down. Now this is example 3.5. Let me make sure I window tile right. Okay, so this is all you have to do here. One thing to keep in mind is that the cosine function, and I'm going to go to help, show context help. I'm going to hover over the cosine, and notice that the context help up here says computes the cosine of x where x is radians. So we have to make sure that we're in radians. Okay, so if you have an angle in degrees, the formula for converting to radians is you have to multiply that by 2 pi and then divide by 360. Okay, so because there's 2 pi radians in 360 degrees. Alternately, you could have used pi and 180. But the important thing is you have to convert to radians. Now, where do you find this cosine function? Well, let's right click, and you're going to have to look in mathematics and go to elementary and trigonometric. And there's where you're going to find all your trig functions. And I've got my cosine there. So just as a check, I know that the cosine of 60 degrees should be a half. So let's run this continuous. I get a half, so that's correct. 30 degrees, yeah, 0.866. So things look pretty good on that one. So we're done with example 3.3. Let's go to example 3.7 now. So let me close this one. And this is example 3.7, front panel. Let's tile left, right. All right, so we've got a while loop. Now, like I said, we should always put visible items, while loop. I've got the 2 ands, a not. So you've got 2 switches here. Now, you can see off is down and on is up. Now, how do you get that? Well, you right click on this, visible items, and there's Boolean text. Okay, so if you're just wondering, hey, is down, which is this? Is this switch on or off? Sometimes it's nice to put that. Now, I've had some problems trying to move that off button or off label, and I just can't seem to do it. But anyway, the idea here is that switches A and B have to be true, in other words, on, for the AND to give me a true. The second AND has to have 2 trues, which means A and B have to be on, and then this emergency switch has to be off because it's going to go false, and then not false is going to be true. So let's go ahead and run this. So if I put one switch up, nothing happens. Second switch, the equipment comes on, and then if I hit the emergency stop, the equipment goes off. The only thing I don't like about this program is I wish I had a way of starting the program with these down no matter what, so that somebody couldn't just power it up and leave the on switches on. I'm sure there's a way. If you figure out a way, show me. I'll give you bonus points or at least an extra bag of candy. Now, where do you get these ands and stuff? You right click and they're all in the Boolean here. And there you go. I think example 3.7 is all good to go. So we'll close that. I'm not going to save any changes. Next one up is going to be problem 3.5 on page 99. So let's go to that one. Problem 3.5, front panel. Okay. Now, I am not going to show you the block diagram here, but this is how I would like you to set up your front panel. So you have to read in the book, problem 3.5 on page 99. You're going to have to apply some trigonometry. So you're going to step off a distance of a shadow. So let's say it's 12 inches per step, and let's say you make 35 steps. And Let's see if this does the rest. This angle that I measure. Okay, problem 3.5. Your front panel should look like this. You're going to input the step length, number of steps, and the angle. So looking at the problem, you then run this, and you get an angle and the height of the person's addition. Now eventually you're going to just run this in continuous mode, and you're going to figure out how many steps it takes before you're over the amount that they give you. And I guess this is 40 degrees here. Don't forget on your sheet, you're also going to want to answer the questions A and B at the bottom of page 99. You might want to just type those right into your VI if you like. Assume your feet are correctly 1 foot and determine the height of the addition. That's number 1. And how far off can the length of a foot be? So you're going to mess around with those things. All right, so there is problem 3.5. Let's go to problem 3.8 on page 102. Show you the front panel. Alrighty, so we're going to set up a little like circuit. You can see all the things in white here are numerical inputs. They're all going to be double precision. I'll just show you that. Data type, double precision. So even though they seem like integers, they are floating point numbers. All right, so you've got 5 things you put in: the input voltage, the output voltage, and then your resistors. And then the current is going to be calculated. All right, and on your sheet for homework, it gives you the formula to calculate these currents, which is going to be V in minus V out, that quantity divided by the resistance. So the current can go through one of 3 paths to get between the 2 voltages. Now, how do I put these little lines to look like circuit wires? Don't forget, we've got right-click decorations. Whoops. Right-click decorations, and you can just use the old thick line and make this look really nifty. All right, so nothing really hard about this one. So I'll close this down, and we're heading into, we did problem 3.5, 3.8, instructor problem 3.1. All right, so we've done this before where we're getting the roots of an equation A, B, and C. And last time we did it, we had all kinds of multiply and divides. I want to show you an easier way to do this. Okay, so window, in fact, I'll just show it to you. All right, this is the block diagram. So you're going to have your 3 inputs, and then down here, so you have these things called formulas. Watch how much easier it is to use the formula than other things. All right, so first of all, where do you get the formula? You right-click, and we are going to go to Mathematics, and Scripts and Formulas down here. All right, so I come in here, and there's a formula block. So I come in, and I bring this in. Okay, so I'll just get you started. Let's say you want to do negative b plus 4ac square root. Okay, now as long as this box over here is lit up, everything's okay. Now before you get started, you need to put in the variables that you're going to use. Okay, so I have variables a, b, and c. So define your variables that you're going to use. It looks like we can use up to 9 different variables. So there's that. So a is something I'm allowed to use. But let's start with negative. Now it says it's invalid. You see that it's gray now. Negative b, now it's valid again. Now this editor doesn't like spaces too well. Sometimes it'll take a space. I would recommend you don't put blank spaces in here. So negative b plus, let's say, the square root. Now what's the function for square root? Well, it's right here on the dial. Okay, so anytime you can click on something, click on it. Don't type it. Square root of b squared. Okay, well, b, can I click on x2? Yep, there's b. Now, how do you do squares? Well, notice square root is here, and you got double asterisk. Now, you say to yourself, I don't know how to do it. Well, don't forget, let me just hit cancel for a second here. If you don't know how to do something, go to help, show context help, hover over this, and go to detailed help. Okay. Now, in detailed help, it gives you all the different operators that you have to work with the formula palette. And notice double asterisk, enter double asterisk in the formula. This operator computes the value of x raised to the power y. All right, so I'll turn off context help. So you're not always going to have John Waddick here spoon feeding you. Okay, so get in the habit of using help. So I come in here, you can just double click on it and come back here. I have to do everything over again quickly. A, B, C. So quickly, negative b. Now, if I hit space, I get an invalid formula. Doesn't like spaces. Remember that. Negative b plus square root of b squared, which we know is this thing now, minus 4 times a, and I can use times here, c, which is here. And it's still invalid because I've got to put that there. So once you get green, you're okay. Now, once you get that, the formula task is going to have three inputs, A, B, and C, and then one output called the result. So from there, I think you can figure it out. But I think you can see that doing something like this is probably easier than wiring up a lot of multiply, divide, square root, and stuff with regular Labview programming. All right, so let's close this one down. Instructor 3.2. All right, so this one, all I'm going to say is it should look familiar to something you've done before. I'm going to run this in continuous mode. If you put in something like 41, it's going to be the fewest number of coins that have 1/4, a dime, a nickel, and a penny. And I'm going to give you one hint. We've used the remainder quotient function before. Okay, so go and do that. If you forgot what it looks like, let's just show you a new blank VI. All right, so remember in numeric, remember if you want the quotient remainder function, you can go into numeric, and right up on the top it is this. So this is what you're going to want to use. The remainder is on top, remember, the quotient's on the bottom, and that'll allow you to do integer division. Now, one of the things I would suggest, I'm not going to save, is this change in cents over here. Let's just look at what property I have on that. Data type, I would suggest you use an unsigned integer because you're never going to have any fractions of a cent, nor are you going to have negative cents here. So probably even a U8 will get us to 255, but U64, plenty good. All right, that's it for your hint on 3.2. 3.3 is going to be a spoon feed to you, and I have it right here. And notice that I have put all my my functions in there, random number, so you can hunt around for these. Let's see, can I now where are you going to find this time delay? Well, we can right click, and up in here there's a timing, and we just click over here, time delay. And when you do that, you can expand this out. So let's just put OK. There's the time delay. And you can right click and you could create a control. All right, so that's the time delay too. So the time delay will make it so that your function will slow down and you'll have time to see what's happening. So for instance, let me start this with a time delay of 0. Okay, so the idea is someone's going to input the input integer is 5, and we're going to see how long it takes for this random number generator to equal 5. In fact, I'll change it to 6. All right, so I'm going to start that. We'll run it. Bam! It looked like it happened instantaneously. We didn't even get a chance to see what happened. All of a sudden, it took 4 iterations. Let's run it again. This time it took 13 times around. It's still too fast. So let's put a time delay of 1 second here and watch what happens. So here it gives you enough time to see that, oh, the random number generator is creating random numbers. If that's still going too fast for you, go 2 seconds. So it's guessed 7, then it guessed 3, then it guessed 10. It's up to 3 iterations, then 4, and it's going to keep going until this random number generator matches our input integer. Now, one of the other things I want to show you here is a very nifty feature that let's put this as 2 seconds that Labview has. It's called highlight execution. Okay, so this little light bulb. Now watch what happens when you highlight execution. When I hit run now, you're going to watch numbers as they flow through these wires, and then you're going to see the sequence of results. So hopefully it'll go slow enough. I don't know if we can change the parameters, but let's go ahead and run. So first thing you're going to see is this integer, and let's just make it 8 this time. This integer, which is going to be 8, is going to come into this loop from outside. So something from outside coming in is going to be done first. So let's go ahead and run it. Got an 8. 8 came in over to here. Now it went through these operations, and it went pretty fast. So each time 8, and then it's going to do a random number between 0 and 1, scale it up, and see if this computed random number is equal. If it's not, it's false. It doesn't stop. This little iterator down here keeps track of how many times we've gone through this operation. As you can see, it kind of goes kind of fast, except the time delay. So run that and just kind of see the neatness in that, and we can abort the execution. Okay. So essentially what's happening is we're taking a double precision number between 0 and 1. We're multiplying by 10. That'll make the number go from basically 0 to 10. We're going to round upward, okay, and that'll be our final answer. So this right in here, the bottom that goes into equal is either going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. And then this number of iterations keeps track. Now, what about I? What value does I start with? Let's watch. 0. So it has 0 plus 1. Now, it doesn't do this addition 1 until it finishes the loop. Okay? So that should be some fun and just shows you a little glimpse. Sometimes if you're having trouble with a Labview program, it's nice to run it in this mode and you can see what the numbers are. There's some other things which we'll use later, which are going to be pauses and single stepping. Those are good as well. I'll just show you a quick single step. All right, single step has this, which it says it's running. So I think we just keep hitting steps, and it does one operation at a time. So now it's blinking. You can do that operation, then this operation, then the next one, and it shows you result by result what's going on. So single step is another nice feature in addition to highlight execution. Make sure to take highlight off before you want to run regular. All right, that's all I've got. I hope you enjoyed Chapter 3, and well, good luck doing Labview. I'll see you in our next chapter.